In today's class, we are looking at modular arithmetic. Good evening and welcome. Modular arithmetic is used to predict the future of cyclic events. And the question is, what are cyclic events? Cyclic events are events that follow a particular pattern. They occur periodically, following that same pattern. For example, we have the days of the week, Sunday to Saturday, back to Sunday again. So it follows that cycle. Here in the eastern part of Nigeria where I am, there are 4 market days, the native week. We have Eke, Ore, Afo, Nkwo, and it goes back to Eke. When you look at the months of the year, we have January through December, and it goes back to January again. When you look at the face of the clock, it is 12 through 11, and that way it keeps rotating. So today we want to study these cyclic events such that we can use these cyclic events to tell what may happen in time to come, a future time. For example, one may ask, if today is Monday, what day of the week will it be in 23 days? You should be able to tell with the knowledge of modular arithmetic. Someone could ask, if today is Sunday, what day of the week would it be in 1000 days? Yes, you should be able to tell. The same thing is happening here. One could say, if today is Eke market day, in 30 days, which market will hold? One could also ask us, if it is 5 o'clock on the clock face, in 53 hours, what time will it be? So that is why we say we use it to predict, we use it to tell the future. Sometime earlier in the year, calendar of years will always be everywhere on the internet spaces, where people will compare the calendar of different years that are exact, that are the same. It is as a result of modular arithmetic, and I'm going to explain that clearly to you. The secret is this. Remember, we have 365 days in a year and 366 in a leap year. So when we have 7 leap years, then we have gone through a complete cycle, and that would be in 28 years. So every 28 years, the calendar will be the same. What are we saying in effect? We are saying this is 2025 minus 28. Okay, 15 minus 8 is 7. 11 minus 2 is 9. Here we now have 9 and 1. What we are saying is that 1997 calendar is the same thing as the calendar for 2025. You can Google it and see things for yourself. So for next year, being 2026, you should be looking at the calendar for 1998. If you still have it in your house, then there's no need buying a new calendar because everything will still be the same. Okay, that's by the way. Now, for what we studied today, part of what we studied today, basically, like we said, here we have days of the week. Remember, our movement in modular arithmetic is in the clockwise direction. Because we are talking about days of the week, there are 7 days for the week, and we have number codes attached to each of the days. So let's start with 0, 1, 2, 3, 4, 5, and 6. Where 0 is for Sunday, 1 is for Monday, in that order. And the movement is in the clockwise direction. It's always in the clockwise direction. So if today is Tuesday, which day of the week will it be in, let's say, 30 days? Tuesday has the code 2. So we start our counting at 2. We're going to count 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 30, we have 4 here, which is for Thursday. So we're saying that if today is Tuesday, in 30 days, it's going to be a Thursday. All right. We can try it for any other day. Well, the issue is this. What if somebody says in 380 days? Which day will it be? If we keep counting like this, we might even make mistakes. So there is always a way out of it. Now what do you do? Today is Tuesday. Tuesday has the code 2. And we are saying in 380 days. So we say 2 plus 380. That will give us 382. Now what are we doing with this? We will divide it by 7. Reason being that we have 7 days in a week. So 7 in 38, in 35 we have 5, remainder 3, 7 in 32, in 28 we have 4, so the difference is 4, remainder 4. Here we are not interested in the quotient, we are interested in the remainder, and that 4 corresponds to Thursday. So we're saying that if today is Tuesday, that in 380 days it is going to be a Thursday. We'll also look at this. Let's talk about the market days. If today is, let's say, Orie, we have the second for that one. 0, 1, 2, and 3. Why do we have just 4 points on it? There are 4 market days. It is that simple. So, if today is Orie market, which market will hold in, let's say, 83 days? In 83 days. Today is Orie. Orie has the code 1. 1 plus 83 will give us 84. Now, what are we going to do with this 84? We are going to divide 84 by 4. Why are we no longer dividing by 7? We divided by 7 here because we have 7 days in a week. Here we are dividing by 4 because we have 4 market days. Okay, so 4 in 8 will give us 2, 4 in 4 is 1. The remainder is 0, and 0 corresponds to Eke market. So if today is Orie, in 83 days it is going to be Eke market day. Alright, now the question is, okay, let's do this one more before we talk about what I want to take us to. Let's look at the clock face. We have 12, 6, 3, 9, 1, 2, 4, 5, 7, 8, 10, and 11. Okay, and if it is 4 on the clock face, what time will it be in 103 hours? What time will it be in 103 hours? So what do we do? It is 4, so we write 4 plus 103. 4 plus 103 will give us 107. We are here we are dividing by 12 because there are 12 points on the clock face, from 12 through 11 or from 1 to 12, whatever. So when we divide by 12, 12 in 107, because 12 cannot divide 10. 12 in 5 is 60, we have 72, we have 84, we have 96. The next one is 108, so that 96. The remainder is 11. Yes, 96. The next one should be 108, but what we have here is 107. So what we are saying is that if it is 4 o'clock on the clock face now, in 103 hours, after 103 hours, it will be 11. That's just it. Okay, now the question is, what if somebody says, yes, today is Thursday. Which day of the week was it? Let's say 65 days ago. Question could come up that way. And in modular arithmetic, our results can never be negative. The reason is this. Just like I asked this question, you cannot tell somebody it was minus Wednesday. It doesn't make sense. So every result we get must be converted to positive, even if it is negative. We must convert it to positive. Now, we said if today is Thursday, which day of the week? Okay, let's use 65 days. So Thursday has the code 4. And it is going to be a minus because we are moving backwards. Okay, let's start small. Let's start a little small. Let's say today is Thursday, and we want to know which day of the week it was in 18. It was 18 days ago. So this is Thursday has the code 4. So 18 days ago. Instead of moving in the clockwise direction, we are going to move in the anti-clockwise direction. So we'll be counting this way. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 days ago, it was a Sunday. It was a Sunday because it landed us at 0. Now the question is, what if we want to do it this way? Want to use this approach? We'll now say 4 minus 18. 4 minus 18 is actually minus 14. But what can we do? Since we have 7 days in a week, so if we get any result, we are supposed to divide by 7 and get a remainder, fine. So what we will do is to keep adding multiples of 7. It will not change our result. So let's keep adding multiples of 7 until we get a positive result. The first multiple of 7 is 7. And if you add 7 to minus 14, the result will still be negative. After 7, the next one is 14. Now let's see, minus 14 plus 14 will give us 0. And 0 is non-negative. So, giving us the same Sunday. We want to take it again. We want to say, if today is Friday, which day of the week was it in 235 days? Was it 235 days ago? Today is Friday, and we are talking about 235 days ago. 235 days ago. Okay, let's see how it goes. Friday has the code 5. So we write our 5 minus 235. That will give us minus 230. So we'll start adding multiples of 7 until we get a positive result. So let's see the quickest way we can do this. Can 7 divide 230? 7 in 23. In 21, we have 3. The remainder is 2. In 20, we have 2, remainder 1. So let's add 7 times 33. 2, we were supposed to write, the first one was 3, and the next one was 2 point something. So if we add, let's say 33 times 7. 7 times 3 is 21. 1 carry 2. 7 times 3 is 21 plus 2, 23. So we're going to add 2, 3, 1. I hope you understand this. 2, 3, 1. And this will give us just 1. If you're owing 230 naira, when you get 231 naira and pay your debt, you'll be left with only 1 naira. And this one is the code for Monday. So we're saying that if today is Friday, 235 days ago was a Monday. I want to still repeat this. Remember, what we had was 5 minus 235, which gave us minus 230. Now, if I start adding 7, it will take a whole lot of time. So I'm trying to get my answer faster. What did I do? I had to divide this by 7 and see what will happen. So when I did that, 230 divided by 7. 230 divided by 7. 7 in 23 is 3. 7 times 3 is 21. This one is 2, and you bring down 0. 7 in 20 is 2. 7 will go through 2 times. So 7 times 2 is 14. The remainder is 6 before you add your decimal. So we've got 32 whole number, and there is still a remainder. So what the best thing we can do is to just add 1. 32 plus 1 is 33. You now multiply your 33 by 7. whatever it gives you, add it to this negative number, and it must land you to a non-negative result, must give you a non-negative result. So what we got was 231. When we multiplied 33 by 7, we got 231. And then minus 230 plus 231 gave us 1. So we're saying that if today is Friday, 235 days ago was a Monday. Okay? And then I hope this helps a long way in making us understand modular arithmetic. We'll be solving some problems now.